Hi guys, today we will start with the concept of minimum cost spanning tree. Already you know what is meant by a spanning tree. Spanning tree is a type of a tree. The whatever the vertices you have in a graph, all the vertices we should have in a tree. That tree we call it as a spanning tree. Now coming to the minimum cost spanning tree. So what is this minimum cost? Now here the weighted graph will be given to us. So weighted graph is nothing but the weights are assigned to each and every edge, that we call it as a weighted graph. So from the weighted graph we have to find out the minimum cost spanning tree here. So minimum cost is, if you add all the weights of the tree, it should be of minimum cost, that we call it as a minimum cost spanning tree. So the cost of a spanning tree of a weighted undirected graph is the sum of the cost of the edges in the spanning tree. A minimum cost spanning tree is a spanning tree of minimum cost. Just as I said, it should be of minimum cost. So if you add all the weights of the tree, that should be minimum, that we call it as a minimum cost spanning tree here. So here we have three different algorithms for finding out the minimum cost spanning tree. The three algorithms are, the first one is a Kruskal's algorithm, the second one is a Prim's algorithm, and the third one is a Solin's algorithm. So these are the three algorithms what we have for finding out the minimum cost spanning tree. Now whatever the spanning tree, the minimum spanning tree you will be calculating, that should satisfy the following conditions here. So what are the following conditions is, we have to use the edges only of the graph. We should not create a new edge. Whatever the edges you have in a graph, the same edges only we have to use. That is one condition. And we should have exactly n minus 1 edges only. We should not have more than n minus 1 or less than n minus 1 edges. That is the second property. And not use the edges which produces a cycle. As already we know, the tree is open, it should not form a cycle, so we should not consider the edges that are forming a cycle. So these are the three properties the spanning tree should satisfy. So we will move to the algorithm. The first algorithm is a Kruskal algorithm. Kruskal algorithm. So Kruskal algorithm is one of the algorithm to find out the minimum cost spanning tree here. So what we will be doing is, we will be adding edge by edge, one edge at a time to a tree, such that the number of edges will become n minus 1, and if you add all the weights, the cost will be becoming minimum. So that is the concept of the Kruskal algorithm. So this is the algorithm what we have. Algorithm is very simple. First thing is, we are taking T. T, initially we don't have any edges, it is empty. In the tree we don't have any edges, it is empty. Now while T contains less than n minus 1 edges and E is not empty, if this is true, then what we have to do, we have to choose a least cost edge from E. E is a set of edges. From that we have to choose the least cost edge. Then what we have to do is, from the edge list we have to remove the edge whatever you have selected. Now if it is does not create a cycle, then that particular edge will be added to the tree. If it is not creating a cycle, then that edge will be added to the tree. Else you will be discarding that particular edge what you have selected. This is the close of while loop. If T contains less than n minus 1 edges, if all the edges are completed and but the T is containing less than n minus 1, then you have to write that there is no spanning tree possible. So I'll explain you the step by step of the algorithm with an example. So this is the example what we have. And here this, if you observe, it is a weighted graph. Why it is a weighted graph? Because the weights are assigned to each and every edge here. So this is a weighted graph here. Now what I am doing here is, I am writing the edge list here. Writing the edge list, and how I have written the edge list is based on the ascending order. So 0, 5 is having the minimum weight here, 10. Now 2, 3 is having the next minimum, where is 2 3, 2 3 is 12. So next is 6 1 is 14. So I am writing the edges in the ascending order. This is the first step what I am doing here. Now what I have to do here is, since it is a spanning tree, minimum cost spanning tree, whatever the vertices you have in your graph, the same vertices you will be having in your tree also. That is the reason, whatever the vertices you have in the graph, the same vertices I have taken here. This is my figure number A. Now what I'll do here is, what is my first step? Now initially tree is empty, we don't have any edges. Now what I have to do is, if t contains less than n minus 1 edges, yes, we don't have any edges here, and e is not empty, and e is not empty here. How many vertices you have here? You are having 7 vertices. That means n equal to 7, and the number of edges should be 6 edges we should have. But here initially we don't have any edges, e equal to 0, and edge set is also not empty. So we have the edges here. So now what we have to do, choose a least cost edge from E. From this edge set, we have to choose the least cost. Already we have arranged in the ascending order. So what we will do is, we will select 0 5. So we have to choose a least cost from E and delete from V comma W from E. So I am selecting this, I am deleting from this edge set now. So I am writing the edge set. So what is will be my edge set now? I have removed 0 5. So what I'll get remaining, 2 3 2 3 6 1 1 2 6 3 1 2 6 3 4 3 4 6 4 3 4 6 4 5 0 1 4 5 0 1. So after choosing this vertex with the minimum, what I have done, I have deleted from this. So we have to choose and delete from E. Now we have to see if does not create a cycle. So this is the 0 5 is the first thing we are considering. If you take this, is it forming a cycle? No. So since it is not forming a cycle, what we have to do, we have to add to the tree now. So I'm adding 0 5 to the tree. So I will take the figure B now. So 0 1 5 6 4 2 3. Now what is the edge I have considered here? 0 5. So 0 5 is the edge I have considered, and the cost of that is 10. Is it forming a cycle? No, it is not forming a cycle. This is the thing. Now I will go with the next step now. Again what we have to do, once again the process should be repeated. Now how many edges you have in the tree now? How many edges you have? You have only one edge. How many edges we should have? It should be 6, less than 6. True. And the edge set also we have. Now the same process should be repeated again. Now select 2 3. Next we are selecting 2 3 because this is minimum. Now delete 2 3. If you delete 2 3, 6 1 1 2 6 3 4 3 4 6 4 5 and 0 1 are the remaining you have. Now let us add 2 3. If you add 2 3, will it form a cycle? No. So what will be my tree again? This is 5 1 6 2 3 2 3 I am adding now 4. Now 2 3, what is the cost here? 2 3 cost is 12. So this is the thing what I am adding. This is my figure number C. Now I'll again select the next vertex now. So next edge. So I am selecting 6 1. So 6 1 I am selecting, and I will remove 6 1 now. If I remove 6 1, what I'll get? 1 2 6 3 4 3 4 6, 4 5, 0 1. I'm selecting. Now I will add 6 1 edge. It doesn't form a cycle. So I'm adding, this is 10, this is 1, 6, 4, 2, 3. This is already we have. Now which one we are adding? 6 1. What is a 6 1 cost? It is 14. It is not forming a cycle. Yes, we can consider this. Now what's the next one? This is figure number D. Now I'm going with the next. I will select 1 2. So select 1 2. If I select 1 2, it will not form a cycle. Okay, now I will delete again 1 2, 6 3, 4 3, 4 6, 4 5, 0 1. Now I will add 5. This is 10, 1 6, it is 14, 4, 2, 3. This already we have added 12. Now which one I am adding? 1 2. It is not forming a cycle. So 1 2, what is the cost of 1 2? It is 16. So this is figure number E. Now next what I'll do is I will select 6 3 now. So I will select 6 3. Select 6 3 and I will remove from the edge set now. So if I remove 6 3, 4 3 4 6, 4 3 4 6, 4 5 0 1, 4 5 and 0 1 I have. Now let me add to the tree now. So what is my tree? 0 1 5 6 2 4 3. Already what we have added? 0 5 we have added, 2 3 we have added, 1 6 we have added, 4 2 we have added, 16. Now which is the thing I have to add now? 6 3. If I add 6 3, what will happen? It will form a cycle. So we should not consider this. So we are not adding now. What we are doing? We are discarding 6 3. Now 6 3 is not added to the tree now. Now this is now the next. What is the next one you have? Select 4 3. Now I will remove 4 3. What I'll get? 4 6, 4 5 and 0 1. Now the tree 0 5, this is 10, 1 6, this is 14, 2, this is 16, 3, this is 12 and this is 4. So which one I have to add now? 4 3. Will it form a cycle? No, it is not forming a cycle. 4 3. So now it is 22. This is my figure number F. Now next I'll select 4 6. Select 4 6. So select 4 6 and remove 4 6 now. If you remove 4 6, it is 4 5 and 0 1. Now let me add to the tree now. So 0 5 1 6 2 3 4. This already we have added. This is 22, 12, 16, 14. Now which one I have to add? 4 6. If I add 4 6, what will happen? It will form a cycle. So what we have to do? Discard 4 6. We are not adding now. Okay. So next what we have to do? We have to select 4 5. So if you select 4 5, only remaining is 0 1. And now let us add to the tree now. 5 1 6 2 3 4. This is 16, 14, 22, 12. Now which one we have planned to add? 4 5. Where is our 5? 4 5. Yeah, it will not form a cycle. So we can add this. What is 4, 5? It is 25. Now if you observe here, totally the number of vertices are 7 and the edges should be 6 here. 1, 2, 3, 4, 5, 6. Here we got 6. So in the next iteration, we will be discarding, that's all. Now select what is our edge you have now, 0, 1. But number of edges is becoming 6. So stop. This is the thing what you will be doing. So this is our final figure. So if you add all the weights, the cost will be 99. So this is 0, 5, how much? 0, 5, this is 10. So if you add 10 plus 25 plus all, the minimum cost spanning tree of this is 99.